All right, here we go. So this is the practice for exponential growth. All right, so we're going to read through the question, see what it's asking us, kind of pick out its key points, and then you're going to see how that original equation is going to come in handy. That's the equation you'll use anytime you are using or talking about exponential growth. We're going to look at this whole equation here. Okay, so it says the population of the United States has been increasing. So there's one of our keywords to know that we're talking about exponential growth at an average rate of 91% or 0.91%. If the population was about that in 2008, predict the population in 2020. Okay, so there's a lot that we have to piece. So we have our A value, our R value, and our T value. So I've put those things over here, but you might want to get your notes out from the first video and kind of keep those where you can see them so we can remember what those values mean. Okay, so A is our initial value that we're starting with. So it says the population was 303,146,000. Okay, so that was the starting population point. So we're going to write that down as our A. Okay, and then R, that was the rate that it was changing, and it says it was going at a rate of change of 0.91%. Okay, we know we can't do percentages in our calculator, so we're just going to go ahead and change that to a decimal. I know it is already technically in a decimal, but it's saying it's part of a percentage point. So in order to change it to a decimal, we need to move that decimal point 2 places to the left. So that's going to be 0.0091. All right, and then the time. So we're going from 2008 to 2020. All right, so you're not going to put one of those years. It's the amount of time that is passing from 2008 to 2020, which is 12 years. Okay, so now that we know all of our values, we can plug those into our equation. So I'm just going to put that up to where we can see it. So Y is what we're solving for. All right, and then our A. So that's 303,146,000 times 1 plus R, which is 0.0091 to the T power, which is 12. All right, so now all you have to do is follow order of operations, plug all of that into your calculator, and you are going to get Y equals 337,950. Okay, so what the heck does that number mean? Okay, well, Y is going to tell us what that exponential growth is. It's going to tell us the population, what their prediction of what the population would be in 2020 based off of what the population is now, how quickly it's increasing. And so they think it's going to be 337, almost 338 million people in 2020 in the United States. Okay, so let's go look at the next one. All right, it is estimated that the population of the United States is increasing, so there's that keyword again, at an average annual rate of 1.3%. Okay, so now we're talking about the world population. Earlier we were talking about the United States population. If the 2008 population was about 6.6 billion, predict the population in 2020. So we're going from 2008 to 2020. Alrighty, so let's look at it. So our A, that's our initial amount. So what is the population right now in the world in 2008? It's 6.6 billion. Okay, so we're going to write out that big number, 6. Lots of zeros. Okay, All right, and then at the annual rate of 1.3%. So we need to change that to a decimal because we can't type that into our calculator. So that's going to be move it two decimal places to the left, so it's going to be 0.013. And then time, again, we're going from 2008 to 2020, so once again, that is 12 years. Okay, so we're going to take that and we're going to put it into our equation, and that's t. All right, so again, we're solving for y, so we'll just leave that as y equals a is that very long number, 1 plus 0.013 to the 12th power. Okay, so if you want to add those together, that's going to become 1.013. Okay, really the rest of it, you just type it all into your calculator. This one would literally you be able to do it on most calculators. And you are going to get y equals 7754 375 446. Okay, so that's what they predict the population of the entire world to be in 2020, based off of the current population and how quickly it's increasing now. Okay, so that's the formula that everyone uses, like in the whole world, to make those types of predictions. All right, now let's look at exponential decay and look at those. Let's try to spot those keywords that help us know that that's what we're talking about, that we're talking about how much something is decreasing. So it says Nathan bought a very fancy boat for $125,000. If the boat's value depreciates, which just means that just like if you bought a brand new car and you drove it off the lot, it immediately loses some value because it's used. Okay, so same is true for a boat. Okay, that's what depreciates mean. It means it loses its value. At a rate of 15% per year, what is the value of the boat at the end of 10 years? All right, so let's see what information it gives us. So A, remember it's the same thing for growth and decay. So A is that starting amount. So the starting amount of the boat was $125,000. Okay, and it loses its value at a rate of 15% per year. So we got to move that decimal place 2 places to the left. So 0.15 per year. All right, and then it wants to know after 10 years. Okay, so this one didn't tell us from 1 year to the next. It just told us how many years we're looking at here. All right, so how much is this boat going to be worth in 10 years is basically what it's asking here. So we're just going to take that information, we're going to plug it into our equation. The only difference between the exponential growth and decay is now we're subtracting that rate from 1 rather than adding it to 1. Okay, so we have y equals 125,000 times 1 plus, minus 0.15 to the 10th power. Okay, so that's going to be 125,000 times 0.85 to the 10th power. Okay, and then we would get 24,000 So this is what, so if Nathan wanted to turn around and sell his boat in 10 years, that's how much it would be worth. So not a very wise investment by Nathan if he's planning on selling it, because it went from being worth $125,000 to barely to being a little less than 25,000 in 10 years. Okay, so I don't know. Next, wait, let me go back. I forgot to label this. Yeah. Next, we have Olivia buys a new car that costs $32,000. I cannot talk. $32,000. The value of the car is expected to depreciate again. So just like I said, it loses its value at 8% each year. Find the value of Olivia's car in 6 years. Okay. So we are going to just type that in, or get all the amounts we need. So the initial amount of the car was $32,000. It depreciates at 8%, but we need to write it as a decimal. And then the time is over 6 years. So we're just going to plug that into our equation. And so the car would be worth honestly not too bad. Okay, so if Olivia wanted to turn around and sell her car in 6 years, it's still going to be worth quite a bit of money. Okay, so but you can see how much it lost value. I mean, it lost about $13,000 of its value in 6 years. Okay. Last one, we're talking about compound interest. And just a reminder, compound interest, again, is if you don't pay off your credit cards, or you don't pay your bills, or if you, or at a positive, if you have savings, it builds interest over a period of time, so you're actually gaining money. Okay, so that's what it's talking about, compound interest. All right, so this is the formula. It's a little bit different, but still we're gonna go through the same process. So let's pick out those key points that we need. So P is the initial amount we're starting with. R is the rate that it's changing. N is the number of times that the interest is added, and then the amount of time that's passed. So determine the value of an investment of $25,000 if it is invested at an interest rate of 5.25% compounded monthly for 4 years. Okay, so this little part right here where it says monthly, oh, okay, nope, that's too thick. All right, so it's compounded monthly. So every single month, like for a credit card bill, it's going to apply that interest to it. So in order to know what that amount would be for this N value down here, you're gonna have to think about it for critically a little bit. Like if it's every single month, how many months are there in a year? There are 12. Okay, and then it's going to do that over 4 years. So then you just multiply that 12 times 4. Okay, and so that's this portion right here. All right, and then we have our starting amount. So we're starting out at $2,500, and then the rate is 5.25%. So we have to again move that decimal point over 2 places. And so there we go. So we have all of our information. We're just going to now plug it into our equation. So we have y equals p, which is 25,000, times 1 plus 0.0525 divided by 12 times 12, or to the 12 times 4 power. Okay, so I'm going to minimize my screen a little bit and pull up the calculator. So if you have access to a calculator at home, you could see how to type all of this in. All right, so the first thing I need to do is I need to make sure that I'm following order of operations. So I need to do my parentheses first, and then I also need to simplify this exponent. Okay, so I have y equals 2,500 times 1 plus, let's do this little bit right here. So I have 0.0525 divided by 12. Okay, and then so that's what that equals. So I'm just going to go ahead and add 1 to that. Okay, so that's going to be 1.004375, and then I have 12 times 4, which is 48. Okay, so I'm going to just go ahead and I'm going to multiply that all out. All right, so in the end, this is going to equal y equals 3,082. And since we're talking about money, we're going to go to 2 decimal places. So it's going to be in 78 cents. Okay, so if you invest $2,500 over 4 years with this interest rate, you'll end up with a little over $3,000. Okay, so you just got basically $500 of free money over that period of time. Okay, last one, and then we are finished. Okay, so it says determine the value of an investment. So you're investing $100,000. If it is invested at an interest rate of 5.2%, compounded quarterly for 12 years. Okay, so there's that little word again. We have, this time we have quarterly. Okay, well, quarterly, what does that mean? That means it's 4 times a year. Okay, so that number of times the interest is compounded, that end value will be 4 because it's quarterly. All right, and it's over 12 years, so then you would multiply that by 12. All right, so the amount that we're starting with was $100,000, and then it's increasing at a rate of 5.2%, which we have to move that decimal, so it's 0.52. All right, and then we are going to plug all of that into our equation. Plus 0.052 divided by 4. 12 times 4. I guess it would be 4 times 12, but it's fine. All right, so let's simplify inside of our parentheses, and we have to simplify that exponent down. So we got my equation. All right, so let's do inside this parentheses real quick. So I have 0.052 divided by 4 plus 1. All right, so inside this parentheses, I'm going to have 1.013 to the 48th power again. So I'm just going to type all of that straight into my calculator. All right, so at the end of that 12 years, if I invested all of that money, I would have $185,000, 888.87. Okay, so that interest, we had a higher interest rate, 5.2%. Okay, that's a very high interest rate in regards to how much it builds off of an amount. So you can see that at the end of 12 years, you end up with almost $86,000 more dollars than you started with, okay? So that's just based off the interest of what is applied to your starting amount. All right, so that is exponential growth and decay and compound interest. And again, that is the last skill. You can kind of see how exponential growth is applied to real world situations. Yep. All right. See y'all guys.